Hello, my name is Kelly Tingle, and I'm a student from Berkeley City College in Berkeley, California. I'd like to tell you about my research project this summer as an intern at JISAO. My project focused on one question: can biological productivity in the ocean be inferred from oxygen at depth? In other words, if you can measure how much oxygen is being consumed in the ocean interior, can it tell you the amount of oxygen being produced at the surface? My research tested a method of determining the rate of oxygen consumption along isopycnals in the ocean. I used model output from a global coupled ocean biogeochemistry model called BLING for my analysis. I looked at two areas of the Pacific Ocean, 103 west in the South Pacific and 152 west in the North. These are areas that have been heavily researched and a lot of data is available for comparison. The surface waters of the ocean are generally well mixed in terms of temperature and density and are called the mixed layer. Below the mixed layer, the ocean stratifies into layers of water that are uniform in density. These are isopycnals. Water parcels full of dissolved oxygen move from the mixed layer into and along their respective isopycnals. In order to determine the rate of oxygen being consumed, the age of the water must also be considered. The age is equal to the amount of time since the water has left the sea surface. Scientists can use atmospheric tracers like chlorofluorocarbons to determine the water's age. Since there is no natural source of CFCs, and they weren't manufactured until the 1930s, it is possible to estimate the age of the water if the concentration is known. So, what's the rate of oxygen consumption of a water parcel as it makes its journey along its isopycnal from point A, the surface, to point B, somewhere at depth? That's what I tried to find out. Since I was using a model, I had an answer of what the rate should be, and I could compare my calculations with the model's answer. Thank you, Rolf, Mariona, and Sabina for teaching me so much, and thanks to JISAO for a great summer in Seattle.